You ever wonder how some apps can find one piece of information, just one thing out of millions, almost instantly? Well, it's not magic. The secret is an incredibly powerful C++ tool called the hash table. And today, we're going to pull back the curtain and see exactly how it works. Look, we've all been there. You're trying to find something in a massive collection of data. Think about scrolling through a phone with millions of contacts, not just a few hundred. This is a real problem for developers working on everything from databases to game engines. Just scrolling through one by one, that's like trying to find a needle in a haystack. It's just painfully slow. Right, so with a basic list, you're pretty much stuck doing what's called a linear search. You check the first thing, then the second, then the third, and on and on. If you have a million entries, you could be waiting a long time. But what if you could just skip the entire line and jump straight to the data you need? And that's where our hero of the day comes in, the hash table. This thing is a brilliant piece of engineering. It's a data structure designed for one primary purpose, to make finding, adding, and getting rid of data just ridiculously fast. So how fast are we talking? We're talking about O1, or what's called constant time. Now, in plain English, this means that finding an item in a hash table takes pretty much the same amount of time whether you have 10 items or 10 million items. The size of the haystack just doesn't matter. So how does this amazing trick actually work? Okay, so the secret sauce behind that incredible O of 1 speed, it isn't actually magic, but it is a really clever process. And it all revolves around something called a hash function. The best way to think about a hash function is like a super efficient receptionist at a giant warehouse. You walk up and give it a key, let's say the word apple, and it doesn't search for anything. It instantly calculates the exact storage locker, or bucket, where that item belongs. No searching, just pure calculation. So here's the four-step dance. You give it a key. The hash function works its magic and creates a unique code. That code points to one specific storage bucket and boom, your value is stored right there. And the best part? To find it again, you just do the exact same thing and it takes you right back to it instantly. Okay, now you're probably thinking, wait a minute, what if that hash function isn't perfect? What if it takes two totally different keys, like apple and banana, and accidentally assigns them to the exact same bucket? Well, that's the central challenge that makes hash tables so interesting. This is what we call a collision. And here's the thing, it's not a bug. It's an expected, totally normal part of how hash tables work. I mean, think about it. You have a nearly infinite number of possible keys, but a limited number of storage buckets. Collisions are pretty much inevitable. The real genius is in how C++ handles them. So to handle these collisions, C++ has a couple of clever tricks up its sleeve. The first is called chaining. You can think of this like each bucket having its own little list. If two items hash to the same spot, you just add the new one to the list. Easy. The other method is open addressing. With this one, if a bucket is already full, the system just says, no problem, and checks the next available one. Both are simple, elegant ways to keep everything running smoothly. All right, so that's the theory. But how do you actually use this thing in your own C++ code? Let's get practical and talk about STD, unordered map, which is the workhorse behind fast lookups in tons of real-world applications. The C++ standard library is awesome because it gives us a powerful, ready-to-go hash table called STD unordered map. Let's say you're storing player scores. You just declare an STD unordered map for strings and integers. Then you can instantly set or get a score just like that. All the hashing, the collisions, all that complex logic, it's all handled for you, right out of the box. So let's say you're in a situation where you need to map keys to values in C++. You've basically got two main options in the standard library, and the one you pick really boils down to one critical question. What do you need more, speed or order? Okay, here's the breakdown. You've got STD map on one side and STD unordered map on the other. Now, STD map is super neat. It keeps all your data sorted by key all the time. But that organization comes at a price. Its performance is O of log n. On the other hand, STD unordered map is the speed demon. It doesn't care about order, it just wants to be fast, giving you that amazing O of 1 average performance. The choice is usually pretty simple. If you absolutely need your data to be sorted, use map. For just about everything else, when speed is what matters most, unordered map is your friend. Now, you might have spotted that worst O for the unordered map and gotten a little nervous. That can happen if you have a terrible hash function that causes everything to collide into the same bucket, basically turning it into a slow, simple list. But here's the good news. You really don't need to worry about this. The hash functions built right into C++ are incredibly well designed to prevent this. Seriously, in the real world, you will almost never run into this worst-case scenario. So let's lock in the most important points. Hash tables give you that lightning-fast O of 1 average speed by using a hash function to map keys to values. In C++, your go-to implementation is std_unordered map. And just remember the golden rule. When speed is your top priority, choose unordered map. When you absolutely need your data to stay sorted, that's when you reach for map.
And that really brings us to the final question, the one you should be asking yourself on your next project. As you're deciding how to store your data, what's the one thing you absolutely can't live without? Is it pure, unadulterated speed? Or is it the reliable, predictable structure of keeping everything in order? Your answer will tell you exactly which tool you need to grab from your C++ toolbox.